Okay, here we go. Section 6.4, separable differential equations for AP Calculus, page 6. In this problem, we have an amount of money that is deposited in an account that is compounded continuously. The money doubles itself in 12 years. How long will it take until the money is worth 5 times its initial value? Since the money is compounded continuously, we know that its rate of growth dy dt is proportional to the amount that's in the account. And we also know when we have this set up, we can automatically come down here and go to y equals some c e to the kt, where y is the amount of money in the account at some time t. All right, well, let's see some information. We know that the money doubles itself in 12 years. How much money was put into the account initially? We don't know. Let's make something up. How about $1,000? So at time 0, y is $1,000. That'll give us then that 1,000 equals some c e to the k times 0, which means that c is 1,000. So our equation now is looking like y equals 1,000 e to the k times t. And another piece of information is that the money doubles itself in 12 years. So at time 12, we put $1,000 in initially, which means we have $2,000 at 12 years. So if we fill that in, we'll have 2,000 equals 1,000 e to the k times, oops, not t here, but 12. Divide out this 1,000, we have 2 is e to the 12k. Now if we raise both sides of this equation to the 1/12th power, that'll give us e to the k is 2 to the 1/12th. Then taking that and substituting out for this e to the k right here, we'll have y equals 1,000 times 2 to the 1/12th to the t, which is 1,000 times 2 to the t over 12. All right, but I didn't ask you for this. I asked you to find out how long will it take until the amount of money is 5 times as much as the initial value. So we want to know when will there be $5,000 in here. So we set this up, 5,000 equals 1,000 times 2 to the t over 12. Dividing out this 1,000, we'll have 5 equals 2 to the t over 12. I'm recording. I'm recording. My husband wanted to talk to me, sorry. Okay, so let's solve this for t. Most of you are comfortable with taking the natural log of both sides. So we have ln 5 is the natural log of 2 to the t over 12. Pull this exponent down in front because of the log rules, and we have ln 5 is t over 12 times ln 2. Multiply by 12, divide out this ln 2, and we have t is 12 ln 5 divided by ln 2. And when you zap that up into your calculator, you will get 27.863 years. So it will take 27.863 years to make your money turn from $1,000 to $5,000. Now, I do have a quick comment here. We arbitrarily chose $1,000. It would not matter if you chose $1. If you put $1 in this account, then instead of C being 1,000, C would have been 1. Then right here, instead of at 12 years, instead of you having $2,000, you would have $2 and a 1 over here. And we divide that out, that's still going to be a 2, and then everything else would be the same. And then we would be looking to see when there would be $5 in the account. So this would be $5, this would be $1, and we'd still end up with 5 here, and simplifying, etc. You still get the same answer. Okay? All right, thank you very much. Please join me on page 7.